Good morning. Today is October 6th, 2018, and this is the John Chappell Natural Philosophy Society Science Chat. And I am your host, Franklin Hu, and we can be found on the web at naturalphilosophy.org. We invite you to join our membership, and you can also find us on social media, on Facebook, and we also are on YouTube channel. Several of our members have their own channels, and you can find recordings of these meetings on YouTube as well. So give us a like on Facebook. If you'd like to help us out, we're always looking for people to join and help organize things, and we have got something called Base Camp, which allows us to do that. So today's an open discussion here, and I was just talking with Michael Anteskis, and it sounds like he's got he'd like to talk about the ether, and it sounds like he's got a new interesting kind of ether. So Michael, why don't you go ahead and tell us what the basics of your theory is?
Well, basically, to start in the beginning, I believe that it involves some kind of a universal oscillation, and the likeliest substrate for such an oscillation would have been original space. Inasmuch as original space would have been free of any kind of forces, it could have been more self-compatible than present-day space, and it could have been more self-compatible, and points of oscillation would have had non-oscillating space between them for oscillatory motion to occur. And so that leads to the concept that elemental, universal point localities of space were what came first. It wasn't a big bang that started the universe. Instead, it was the first thing that happened was this universal oscillation, which produced the universal ether. The next step from the ether would have been transitional from oscillational point locality elemental units to vibrational, likewise massless elemental ether units, in that oscillational fatigue of neighboring oscillating points would have produced combinational yin-yang paired up units, which then, as they would necessarily have had to reversibly revert back to singleton units, would then have fallen out of phase with the oscillations, which would have erased the perfect symmetry of original space. Oscillational fatigue is known to science. It occurs in metals. Thus, the elemental points of the localities of space would have transitioned from balanced oscillating units to vibratory interactive units as the outward vibrations of the units came into contact with each other. This would have produced a universal etheric matrix, whose elemental units would have served as the fundamental building blocks for everything from then on. And,
do you have like a website or a paper or something describing your theories?
Well, I've been inactive at the John Chappell Society for a couple of years. I have had a website which was designed by D. Hilster, but I don't know. I didn't pay my dues for a couple of years. I don't think I still have the website, but I did have it, and Franklin Hu was one of the contributors to that. It may still be there. I tried to check for it, but I didn't seem to find it just the other day.
Well, you're probably still in the scientist database, since we have a tendency
might be in some databases.
Keep as many people in there as possible.
Well, anyway, this model goes on, and it says that, and it goes to from the idea of an etheric matrix, that there would have been an etheric world which preceded our present quantum atomic magnetically structured world, and this previous world would have been etheric, and it would have featured hyperfluxes of etheric energy, which via entrainments and then adjoining entrainments would have produced islands of very high energy, and that a sapient entity could have arisen in such a in such an environment. And then the idea of creational input enters in, where the etheric macrocosm of this prior world was unstable magnetically for atomic and quantum atomic islands that may have existed in this etheric macrocosm. So a atomic quantum world would have had to be produced, which led to our universe as a creational universe. And that then the next step would have been that would have involved the you'd have to account for how antiparticles could have found channels away from the new quantum particle universe, and the likeliest repository for the antiparticles would have been black holes. So this would amount to a first ever rationale for the absence of antiparticles and the presence of black holes in the universe. And this kind of a model also can explain quantum entanglement, because you'd have an unstructured ether matrix composed of elemental interactive vibratory units existing together with a structured atomic world where all the quantum units are made up of the same elemental units. And vibrational packets of such units could have provided a readily explainable model for quantum entanglement, because you'd have a packet of vibrating units between the two quantum particles, and they could become entangled very, very rationally in that kind of a model. So my model has a lot of good points to make, I think.
So I Googled your name, and I seem to have found Michael Anteskis' Aether model here on sciforums.com.
Oh, yes, I've tried those internet forums, but it's sort of like a voice in the wilderness. You know, they're not really scientific. You're not really in the literature with those forums, and you don't really get that far. I don't think. I haven't got that far yet, anyway.
Well, it looks like you've got quite a bit of stuff in this particular forum here. Now, let me ask you about your Aether model. So you're starting out with, it sounds like a fundamental space or something like that you're saying that has something to do with oscillations.
Well, the idea is that original space would have been different from our present space. You can't just assume it was just a void, because it was different. It wouldn't have had any forces at all. It would have been pure space. And if you say that original space was more self-compatible, then to me, that's the only really rational way to explain anything, to explain everything, because how can you start with a Big Bang, the mystery Big Bang that came out of, you don't know where it came from, or so on? It's just a lot of gobbledygook to me. But if you make that one hypothetical assumption that original space was self-compatible via point localities, and then you go from there, you can go to a universal ether, and then you go on to all the rest of it.
What do you mean by self-compatible? I mean, isn't our current space self-compatible? It doesn't blow up or do anything. What do you mean by that?
Meaning that there are point localities, elemental point localities, which were oscillating. And by oscillation, you mean there's each movement of a point is compensated in all other directions, in every single direction universally. And then if this went on, and then oscillational fatigue occurred, then you would have pairing up yin-yang combinational pairs of units. And once that happened, and once the pairs of the yin-yang reversibly reverted to singleton units, that would have erased erased the self-compatibility of space and broken its perfect symmetry, because they would have fallen out of phase with the oscillations once they had combined and then reverted to singleton units. So that's how you could have had an ether.
How is this different from, say, a room full of just ordinary gas? That would seem to be a self-compatible thing. How is that different?
Well, it's kind of hard to explain what original space was. It doesn't exist anymore, for one thing. It's just a hypothesis that you have to make to explain everything. If you start with that, you can explain that one hypothesis, that one assumption, then you can go from there and do everything. Whereas you take a big bang, and where does it take you? Where you come from? You don't know where you came from, and you don't really know how you got to anything else really. I mean, you can't explain quantum entanglement. You can't explain all these other things that this ether model can explain rationally.
Well, in order for things to be rationally explained, you do have to start with your hypothesis, but you're starting with the substance that doesn't exist anymore. So rationally, how can we accept that?
Well, because it explains everything. You go from there, and there's about 10 million things that you can explain rationally with that one hypothesis, with that one initial hypothesis, and everything else falls into place rationally. Literally everything. I mean, you can challenge me with any kind of phenomenon or whatever, and I can relate it to this model. And, to me, it makes the most sense. I guess you just have to say, if it makes sense to you, then it's your bag or something. I don't know.
Well, I'm listening to you, but I'm thinking that it doesn't make necessarily sense that we define a primordial kind of space that doesn't exist anymore. And I'm having a hard time grasping why in the world it would break into this yin-yang sort of thing.
Well, once you got an ether, then that changed space, because now you've got an ether, and you have these tiny spaces between each elemental oscillating and then vibrating ether unit, and then you have to have this tiny space between them for that oscillation to have occurred, and then you've got so it's a different kind of space once the ether develops. Then it's our space, our present day space, which is different from the original space. And I can't prove anything about original space. All I can say is it must have oscillated, and that's the only way. To me, that's the only way it could have happened.
So, what's the importance of these oscillations, and what is the energy source for these oscillations?
Oh, the self-compatibility of space on the basis of point localities, elemental point localities, localities that got so small that they couldn't get any smaller, and then they oscillated with respect to each other, and then you had to have tiny empty portions of space between them. And actually, this goes down to a model of gravity where the tiny portions of space are eliminated when you have a gravitational effect, because between two bodies you have a contraction of the ether, because these tiny spaces are being obliterated in the space because they're becoming more energized from the ether of the bodies, which makes them more energized and closer together, and so gravitation comes down to a contraction of the ether between bodies. So you get all these other rational models come out of that.
Well, it is fundamentally your ether theory. It's a granular ether, that whatever this ether is, that eventually.
No, it's a massless ether. In other words, there's no such thing as true mass in this universe that we have. Everything is made of these ether units. Everything originated in these ether units. All the quantum units and the atoms and everything in our world came from these ether units originally.
So the obvious question would be, how many ether units are in an electron?
Well, this gets into the question of creation, and the idea of a creator of this from the prior ether world um, uh, sending directional electron units into the ether, and then the ether would automatically produce more electrons because of the electrons that were sent into it from the.
That's not the question I was asking.
I'm sorry. I'm trying to get at what is the question again?
How many ether units are in an electron? I'm looking for a number.
Oh, you can't. I couldn't give you that. We don't have any way to analyze the ether, or any way to quantify the ether mathematically or anything like that, because we don't have any way even to detect the ether right now. But it would be extremely rarefied. I mean, it's beyond even. I mean, it would be exponentially and much more than E equals mc squared. It would be more like E equals m to the mc to the 75th power or something like that to get the true rarefication of the ether unit. Compared to an electron, there would be no comparison.
I am still not understanding, why are you talking about rarefication of the ether unit? Is your ether very concentrated, or is it very rare? Like,
well, in
1 cubic centimeter, how many ether units should I expect to be contained there?
There's no way to say, because we don't have any way of quantifying the ether, because we can't even detect it at all. It's just extremely rarefied. And
would you say it's a lot, like billions, trillions?
Well, yeah, a lot more than trillions, actually. The idea is that how the electron came to be out of the ether, and I'm saying that it was a creational thing where you have an ether which is made up of pure ether units, and then you send an electron into it, and then the electron, being the smallest and fastest quantum or subquantum unit, passing into the ether will cause reactions within the ether which will produce more electrons, and then the electrons will produce larger units via entrainment and so on, and then the slower units become nucleated atomic units, and it all happens once the creational projection of the first electron is sent into the ether. Then everything else happens by sort of automatically, because the ether is well, you go by quantum entanglement and how perfect the connection is between quantum units to get an idea of how the ether matrix acts. It's just a universal purring, quiet ether mechanism which acts via vibration, and I can't really characterize the phenomena that closely, because you can't quantify it, because we don't, in our quantum atomic world, we don't have any way of detecting the ether, so we can't really analyze it that closely.
Yeah, but you can understand, as a skeptic, I mean, that sounds like another basically postulate. You're telling us that everything can be logically derived from the acceptance of an ether, but from what I'm hearing is that you can't explain exactly how the electron arises from the ether. So that would seem to be a pretty major break in the logical steps.
Well, as I said before, you had a prior ether world, and in this ether world, you had entrainments of ether units via resonance of the vibrating ether units. Their outward vibrations come in contact with each other, and then this can form entrainments, and then the entrainments can have side resonances and can gradually build up to a larger unit, such as an electron. Or actually, first it would be etheroidal units, and then eventually you would come to the subquantum and quantum units, but that would be further down the line from the etheroidal. First you'd have the elemental ether units, which are the primary units, which the ether, the resonances are vibratory and linear, whereas, of course, in our quantum atomic world, there are spin mechanisms and vectors and this and that. So it's quite different from the etheroidal world, where vibration is the mechanism. So our world is quite different, and it's kind of hard to draw hard and fast connections between them.
But what about other subparticles, like, say, muons, which are like electrons? They have a heavier mass, but they decay. What do you think those things are?
Well, if you want to take the very smallest ones, fermions and bosons, I think that what happens there is you get a gradual buildup of larger and larger etheroidal units via vibratory mechanism of the ether. And elemental ether units gradually build up these etheroidal units, and then you get kind of a shoreline effect where the mass of etheroidal units becomes so great that you get kind of a wave coming into the quantum world, and the shoreline effect that produces the smallest quantum units like bosons and fermions or muons.
Well, how do they do that? I mean, you have this concept of vibrating things. Now, if I have like a ball pit and I start vibrating all the balls, I don't think they're going to spontaneously do anything interesting. They're not going to join together. That's why I have a difficulty understanding how can you build something out of your basic ether units? Why would they want to at all collect together?
Well, because the ether units are interacting via vibration, and it's different from quantum dynamics. This is why Michelson and Morley and all those optical experiments that this supposedly disproved in ether, they didn't take into account the fact that the ether acts via elemental units acting upon the larger units via vibration electrically, and all that Michelson and Morley and the successors considered was that the ether would be a sort of an inert medium for transmitting the photons, optical photons, but they didn't even consider the possibility that an even larger action of the ether would be this electrical action, which would it would not be pure. It would be a transmission medium to transport the photons, but it would also what is going on is this electrical effect, and that's the fallacy of the optical experiments that were done around 1900 or so, before and after 1900. They didn't consider the possibility that and physics still clings to that dismissal of the ether on the basis of those experiments that were done long ago. That didn't include they assumed that the ether, any ether, would act purely as a transmission medium and would not be acting electrically. But if it does act electrically, that invalidates all those experiments, and the ether is still, in the ballpark as far as rationality goes.
Let's talk a little bit about electricity. So in physics, we have the electron, but we also have its antimatter counterpart, which is the positron, which is, nearly as we can tell, has all the same characteristics as an electron, except it has the opposite charge. So in your mind, what is charge, and what is physically different between a positron and an electron to cause that difference?
Well, I'm not a quantum physicist, and you can snow me on that because I'm not an expert on quantum mechanics. But the idea about antiparticles is that creationally antiparticles were channeled into black holes via channels in the ether matrix creationally were directed toward black holes by a like unit channels, like dash unit channels in the ether matrix, because the ether is so much more finely rarefied than the quantum or antiparticles would be. Actually, this is the only way you can rationally account for the absence of antiparticles in our universe, is with a model like this.
How about this? We have this thing called pair production, where if you send a gamma ray into what appears to be empty space in the vicinity of a heavy nucleus, causes the creation of a positron and an electron. So there are no black holes in that vicinity. So how do you explain how that works?
Well, in my model, gamma rays are just electrons, and that the gamma difference between gamma rays or other kinds of rays are just related to cosmic regional differences and observation of the. But I think gamma rays come about when a star is destroyed. When a star gets old and tired, it loses its internal energy and is destroyed. And then the question is, what happens then? I think the atomic signatures are erased, and produces freed up protons and freed up neutrons and freed up electrons, and the protons go to form a new star. The neutrons go to form a neutron star via like unit unit channels in the ether, and then the gamma rays are just the electrons that come out of it.
There's no neutron star. I mean, we can arbitrarily generate gamma rays with like X-ray tube type things. So how is that?
Well, the gamma rays are just the electrons that come out of the destruction of a star.
Yeah, but we can generate gamma rays, and there is no destruction of any star required. We're the ones who generate those gamma rays in these experiments.
Well, I'm still saying they're like electrons, and it's not really. I don't want to discuss quantum physics too much. I'm mostly discussing the cosmos and what goes on there.
Well, I mean, I'm challenging you because you're saying that you can explain all kinds of phenomenon. So I just gave you one. It doesn't sound like you have a very good explanation for it.
Well, gamma rays coming out are electrons coming out of a destroyed star. I think if you have like a gamma ray burst, the enormity of some of these gamma ray bursts are so enormous that there's no way to explain them on the basis of random physics. I'm
not asking you to explain the origin of gamma rays. I'm just saying that we have these experiments which show that positrons and electrons can seemingly pop out of empty space. So have you ever heard of pair production?
Well, what you're calling empty space, I don't call empty space. I call it ether. The ether is composed of elemental ether units, which are the main actors, and then you have the etheroidal units, which also are being acted upon by the elemental ether units and this vibrational resonance mechanism. And then eventually the etheroidal units become large enough so that they can transition to subquantum units like electrons.
May I just ask something following your statement about gamma rays there being streams of electrons? I don't quite follow that. Is this something that you attribute to electromagnetic radiation generally, like X-rays? I mean, beta rays certainly are streams of electrons, but gamma rays and X-rays are not. They're electromagnetic energy.
Well, if I go into cosmic physics, and this discussion was intended to involve the question of alien technology, and I think if you take a gamma ray burst, it's so enormous that you have to have some kind of an explanation. And my explanation would be that there are these technology groups, and that you can have a cosmic system such as a quasar, which is completely chaotic and perhaps going like a wild beast and consuming cosmic regions. And the only way to destroy would be if you have a technology ether technology which can be focused upon the chaotic, non-linear system, that quasar system, to convert it to a linear system, which is where you would have a technology which produces a linear energy, an etheric linear energy, and then you can create a non-random tremendous burst which would be required to destroy such a quasar. So this is how I'd explain a gamma ray burst, which that's different from somebody working in a laboratory and producing gamma rays. I can't correlate the whole thing with that.
But do you conceive of a gamma ray nevertheless as being a varying electric and magnetic field? Is it a transverse electromagnetic wave? As well as what you say, or not?
I don't think we can. I don't. In the cosmos, it's a different world, and from our Earth ambience is more highly quantized, and in the ether world, it's not as highly quantized. Although there are highly quantum realms, regions of space. But by and large, space is more etheric in composition than our near Earth ambience is so different. It's really hard to correlate phenomena in the laboratory with what may be going on in space and what may have gone on with original space. How the ether would have been producing quantum units, it would have to be a creational thing, I think.
Just to point on that, you talk about original space and creational things and so on, and yet you, I think, deny the Big Bang. So the Big Bang would be one theory, mainstream theory, whereby space has evolved and it had a finite lifetime, and at the beginning it had quite different properties from what it did now. Now the other view would be that no, space did not have an earlier form. Well, I'm just wondering, if you conceive of space as having an earlier form, and yet you deny the Big Bang, do you conceive of a sort of a quasi-Big Bang, or an initial production of ether in the universe by some creational event? And if so, what nature was it, and how long ago did it happen, in your estimation?
Well, in the very beginning, everything had to have an initial beginning, and that's where space oscillated, and then you had oscillational fatigue and point localities of space formed in ether because of breakage of the oscillation, and it produced a vibrational ether. Instead of oscillational, it became vibrational. And then, so that produced an ether world, an ether macrocosm, which was immediately preceding our quantum atomic world. And the preceding world was an etheric macrocosm, and there were islands in it which were, the sapient entity had been produced by the hyperfluxes of ether energy that were produced by entrainment of the ether units, and then the sapient entity created islands of quantum atomic islands where you had magnetic structure to it, and however it was magnetically unstable, and so they had to have a universe created in order to provide magnetic stability. And so what was done was taking the fastest and smallest quantum unit, which would be the electron, and mentally or perhaps technologically projecting it into the ether, and then this would automatically produce more electrons out of the ether, and then further entrainments of electrons would produce larger aggregate units such as neutrons and protons, which would be slower and which would form a nuclei, and the electrons would describe arcing motions around the nuclei, and the whole thing sort of happened by itself. Once you started it, the ether would take care of it. The ether is has such a perfect mechanism as shown by quantum entanglement that.
And have you estimated how long ago this may have happened? I mean, say relative to what the conventional Big Bangers would talk about, 13.8 thousand million years ago or something like that. Have you a figure for your own system?
Well, no, all I can say is the beginning would be billions and billions of years ago. I don't know how many. And then the time frames after that would develop according to different mechanisms of energy that would develop afterwards through the quantization. Like in our world is so quantized, especially near the Earth or near a planet or a body, then your energy ambience is quite different from what it would be in the cosmos in outer space. And
you talked about oscillations. Just to get this clear, do you conceive of the evolution, if you like, of the universe as being from this time, billions of years ago or whatever, being sort of monotonic? Or do you think that there has been maybe an oscillation and it's moved one way and then back again and so forth?
No, the oscillations were of individual elemental units. That they're uniform. They're all the same elemental. They're elemental and they're uniform, and that's what began. That's the first thing that happened. Was space oscillated with the elemental point localities of space and slight space, empty spaces between them to allow for oscillational movement. And then the oscillations produced resonances because the outward vibrations would come into contact, and then these resonances would further entrain, and then you'd have larger etheroidal units develop, and then you could eventually have quantum units out of it. And
are those oscillations still occurring? These micro oscillations, or have they been?
No, the oscillation's no longer relevant. That was the original mechanism by which the ether appeared, was via oscillation, and then oscillational fatigue, and then reversion of the fatigued paired up units to singleton units, which would have broken the symmetry of space, and then space became no longer oscillational. Now it's universally etheric, which is vibrational instead of oscillational, and the oscillations no longer exist.
Thank you.
Now, does anyone else have any questions for Michael? I'm just opening this up for questions. Like Harry, you must have some opinion. What do you think about this, Michael's theory?
I don't understand a word of it.
Can you be more precise?
I don't have a clue. Honestly, I don't have a clue. I didn't understand any of it. First off, I don't know what is meant by ether. I wish somebody would tell me what they mean by that word. And I interpret ether to mean some material substance which is known that exists inside of space in addition to space, which seems to be what Michael is saying. But saying that ether is something, I don't know. It makes no sense to me.
Well, if you take like water has a mass in it. It's made up.
Well, you said the ether has no mass.
It's made up of H2O, which is hydrogen and oxygen, which in turn are made up of protons, neutrons, and electrons. So it acts as a mass, and we interpret the waves as indicating solidity or fluidity, And it's really actually a lot of much smaller things acting in concert, well, not in concert, but acting together in a similar way to produce this gross effect. And that's...
I understand that's what most people think an ether is, but what is it? Tell me what it is.
An ether is, it's composed mainly of elemental units which are vibrational, and it also has etheroidal units which are acted upon by the elemental units vibrationally, and our quantum mechanical dynamics of spin and vectors and so on are different.
I'm sorry, I don't understand a word of that. So
it's a transition.
I'm sorry, I shouldn't have engaged in this conversation because I just don't understand it. It doesn't make sense to me. Sorry.
Well, it's a transition. The idea is a transition between the ether and the quantum world, and it's it's a different kind of dynamics, completely different dynamics between the two. One is vibrational. The other one is spin and vectors and those kind of dynamics.
I mean, this is, I think, an important question because I think Harry asked a legitimate question, one which a lot of etherists have a great difficulty in answering, which is, what is the ether? Now, you could say that, someone could claim that the ether was, in fact, H2O, right? You could claim that all of space was filled with water. Of course, there would seem to be some obvious problems with that hypothesis, and that there doesn't appear to be any water in front of me at the moment. Although if I went to the bottom of the ocean, it would seem to be a fairly clear, fairly reasonable way of expressing things. But at least there, I mean, you could understand that the ether was made out of something, right? So, Harry, could you understand that? If I told you that the ether was made out of water, then would that be more satisfactory as an answer to you?
Well, that's Thales of Miletus said that. The ancient Greeks tried to solve this problem, and science really hasn't helped out the idea of a universal substance. And my guess is that what he's talking about, that he calls ether, is what the Greeks would have said was the universal substance, that being that which everything else is made out of. Okay? But modern science has kind of indicated there's no such thing as something out of which everything else is made of. They haven't really found that. And so there doesn't appear to be any such thing according to modern science. So that kind of leaves that whole philosophical speculation sort of out in the cold.
Well, part of the problem is that I'm speculating that everything is made out of a massless elemental ether, and there's no mass to it. It's massless.
That presents a problem.
That kind of contradicts itself, because you're saying an ether is made out of a substance. All substances that we know about that are ponderable, like this stuff, has mass. So you're saying that that's like saying the white block is black. It's like it's a contradiction in terms. So I think a lot of people have a hard time accepting a massless ether. I mean, what's the big deal about it?
Well, there's some advantages to it in that if you have a massless ether, then you can sort of avoid the problem of why it can't be detected by experiments that you would assume that it could be detected by. But since it's massless, then what we detect are particles that have mass. So if it's massless, how can we detect it? So I can see, I mean, I don't know. I can't make any sense out of it.
I mean, I think you're right. I mean, I think it's a cop-out, really. I mean, you're saying that...
I'm not saying that. I'm just saying that I can understand how it makes sense The problem, in my opinion, with ether is if you use the ether as a medium for the propagation of electromagnetic waves, then it has to be a something, a substance, a medium has to have some substantial property to it, and the substantial property is mass. Okay, and that presents the problem that the electromagnetic spectrum doesn't indicate any frequency response. We know that mass systems that exist that are made out of particles that have mass have different frequencies of oscillation. They have resonant frequencies, and they don't have a from 0 to infinity frequency response that's the same. So how can you transmit EM waves through an ether? That would obviously, if it has mass, it has to have some kind of frequency response characteristics. At least that would be my view on it. And you would have to prove otherwise to convince me that it's possible. So I don't see that an ether can have mass because, there's no frequency response characteristics indicative of an ether. So, yeah, that would be, a good way of avoiding that problem. Does that make sense to you what I said?
I think, Mitch, you raised your flag. Did you have a comment?
Thanks, Franklin. I wanted to kind of chime in on this because I have a lot to say about ether myself. And I share a lot of Glenn Borchardt's views on the ether. I'm not sure if you've read any of his books, Michael. But he, we both kind of believe in a kind of a infinite hierarchy cosmos theory, in that it kind of infinity goes up and down to infinity, and that the ether is actually have a very good explanation of what the ether is. Ether particles, there's multiple levels of ether. Now, level 1 ether is the atoms of, or the elementary particles of atoms. And then there's ether 2, which would be the elementary particles of those. So just like we look at atoms as making up all of our substances, or the ether, or the atomic particles are made up of ether, which are like their atomic particles. And they're too small. They fulfill a lot of the questions, like they're too small to detect, but yet they do have mass, although it's very, very small, just like atoms have mass, but it's hard to detect that mass on a normal level for us because they're so small. I just kind of wondered if, Michael, if you've read any Glenn Borchardt's views or books, and what you think of these types of views.
Well, I might as well come out with what way I got my model was was by code breaking of a document, a historical document that I believe was encoded by otherworldly entity, and that's how I developed my model. It's not really my model. It's something that I decoded out of this. I mean, I kind of wanted to stay away from that because it's not really in the scientific tradition to bring in cryptography, but that's really how it happened, and that's one of the reasons why I believe in my model so strongly, because I think it reflects a level of cosmic experience, knowledge that we don't have here in our Earth environment, which is highly quantized, and the ether and the transitions between ether and quantum dynamics. I just defer to this source that I use, and that's where a lot of my confidence comes from in my model as compared with someone else's model. I'm not disputing that there could be such a thing as mass, but I have to ask where did the mass come from? I mean, you have to go back to something in the beginning, in the very beginning. Otherwise, where is your model start? I don't know. I don't understand these models that don't have a beginning. I mean, you have to start with something.
Yeah, I guess in this model, the infinity cosmic model, or the infinite hierarchy cosmic model, just like in size, there's infinity goes in both directions. Actually, in time, it does also. So there is no real beginning or ending.
So we are getting into a little bit of what I had originally talked about, which was this origin of ancient technology. So it's interesting to hear, Michael, that you had gotten some of these from ancient texts. It's like a lot of people will point to, say, ancient Sumerian texts or ancient...
No, it's not that. It was the Declaration of Independence. But I think Jefferson was not the true author of the Declaration. I think it was done by some other worldly entity. And,
really, you got your theory off of the Declaration of Independence?
The code encoded. It is encoded. At least, I claim that it is, and that's where I got all my information from. A lot of it. Well, I figured out some of it along the way, but mostly it's the basic ideas come from that.
So you think you decrypted something in the Declaration of Independence, which had this kind of theory in it?
Well, I can give you the reference. The Declaration codes were discovered by a Canadian author named Neil Dunfield, Dunfield, in 1990. He wrote a book called Not So Self-Evident Truths, and he has how to break those codes and the method used and how to do it, and that's where I got the idea.
I'm going to do a little search here. What was his name exactly?
His first name is Neil, Neil. His last name is Dunfield, Dunfield. And he's the one. He's not a scientist, and he didn't want to collaborate with me. He felt that anyone wanting to work with such codes should do so entirely on their own. And so we worked independently, but I'm more of a scientist than he was. So that's how that happened.
Let me see if I can find anything. Neil Dunfield, Declaration of Independence Codes. Declaration of Independence. I'm not really finding anything right off the bat, but...
Well, I think you have something right there, just underneath. You just had it until you...
which one of these? You see something?
Well, you just had it, and now you lost it.
Well, that's in the search terms here.
Well, he did have a book, and it might be out of print now. It's Not So Self-Evident Truths, 1990, and that's where he tells how to break the code in the Declaration of Independence.
So what was that name? Not So what?
Not So Self-Evident Truths. The title is bad, but the book is very good.
Not So Evident Truths.
You have to put it in quotations.
If you see if the book is available on Amazon, Franklin.
Not books.
It might be.
Check that, maybe.
You have to put book afterwards.
Book? Okay, let's try that.
Comma book.
I don't think it's that smart, but let's see. We do have access to the internet now, so we can look up virtually anything instantly.
Well, either that or go directly into Amazon and see is it there.
You just had it.
Let's see here if Amazon, in fact, has everything in the world. But I see, Bill, you raised your flag. Do you have some comments? here or something like
That's
that.
it there.
Covering the Freemasons game. That might be it.
I have to click on
Yeah,
it.
there it is by Neil Dunfield. There we go. There's his book right there. So there you go. Amazon does in fact has everything. But go ahead, Bill.
I was going to say that if you look at the history of natural philosophy, the first models of the universe had all matter made of uncuttable monads. And these monads had no properties such as charge or mass. But when they were put together, they did have the property of mass. And if you look at the ancient, well, we call them universities today, but they called them in the days of the Greeks, they called them academies. And you see that they had a sign over the entrance that said, "Let no one ignorant of geometry enter here to learn about natural philosophy," because they believed that the combination of these monads, the geometrical combination, determined the mass and the type of mass and the properties of that mass. And so, and that sort of agrees to some extent when you look at the concept of mass with Einstein's E = mc squared formula, because these monads, when bound together, had vibrational energy, and that vibrational energy we call mass today. And so that's the way that they would have looked at it in the past. And so if you were to ask them, with the things we know today, what is the ether? And they would say the ether is the electromagnetic field. And it does not consist of, it doesn't have mass directly, but it has, people like Winston Bostick says that when you have certain types of structures in the field, you form what he called a soliton. And the soliton does not have the property of mass, but it does have a shape, and it has fields emanating from it, just like when you had a cyclone or a hurricane or something like that. You have an eye of it, and that's a structure in the field, but it doesn't have a unique property of things like mass, but it extends to great distances, and so that's what they saw. So when you make solitons, for instance, in water in a swimming pool, the soliton extends to all the boundaries of the pool, even though when you look at it in the sunlight and the shadow on the bottom of the pool, it's a toroidal ring, and all the solitons are kind of like toroidal rings. But the ring itself does not have the property of mass. It's only if they get bound together in a structure. So that's another way of looking at what might be the ether. And because these toroidal monads could exist everywhere in the universe due to fluctuations in the field, you can have massive particles at different places, but that doesn't mean that that is the ether itself. That's just something in the ether.
Well, here's the problem I have, Bill.
Uh-huh.
Ether traditionally has been viewed as a material entity that exists in space. Okay. So by saying material entity, you're implying that it has mass.
But that's a very recent idea. The older ideas are not in agreement. For thousands of years, they didn't have that view. That's a recent.
Well, that's, you can argue that, but the point is that basically the ether theories kind of go back. They kind of try to explain magnetism and electricity, based on some kind of particulate entity that supposedly flows that brings them together and interacts and that sort of thing. And I agree that the idea of a particulate ether is kind of not really modern, but it goes back 400 years to the birth of the scientific revolution. But basically, if you say ether, that means to me you're saying a material substance that exists in space. Okay? So if that's not what you're talking about, then you shouldn't use the word ether. That's personally my opinion. I say the word ether is confusing if you don't mean a material substance that exists in space.
Well, the Michelson-Morley experiment, I believe, discredits that view of the ether.
I think if you look at quantum entanglement.
Hold on. So if you want to use the word ether, you either need to specifically state your definition and point out exactly that you don't mean that it has mass, and then you have to tell me the definition of what it is, okay? And that seems to be where this particular concept falls apart.
Well, everyone knows who's a scientist that the electromagnetic field is everywhere in the universe. Everyone knows that. We've never found a place where it isn't. And so what you're saying is, well, the ether is something distinct from this other thing that goes throughout the whole universe and controls it. And the electromagnetic field was measured by Hooper at the University of California at Berkeley to have tensile strength. The field and all electromagnetic phenomena are not action at a distance. They're local forces due to the field having tensile strength. And so you've got a lot of things that you're ignoring, I think, when you come up with these ideas.
I'm not doing the ignoring. I'm demanding a definition. Okay? I'm not ignoring anything. I'm just demanding that you explain what you're talking about. The word ether to me is just, it's meaningless unless you mean something that's material that exists in void space. If that's not what you mean, you better define it pretty clearly, or else it just is a non sequitur and just nonsense as far as I'm concerned.
Well, I would agree with you, Harry. I mean, that's why my theory of ether has always been a sea of positrons and electrons, right? So that's what I say the ether is. I'm an etherist, but so I agree with you. I think that if someone talks about ether, it has to be some material substance, hopefully one that we recognize. And that's usually the biggest problem I have with other ether theories, is that they define this, some other substance that we don't know about as being the ether versus something we do know about. So we do know that electrons and positrons exist. So if you just make a gigantic sea of those things, that's what I would claim the ether is. I mean, does that make more sense to you that it's a sea of positrons and electrons?
Well, my view is that if you're trying to define a universal substance out of something which everything else is built, and you're saying that's the ether, okay, then you're saying that I can explain material existence by the fact that all the objects of material existence are built out of this universal substance. And if you're calling that universal substance ether, I think you ought to declare at the beginning that that's what you're talking about. Bill is pretty clear that he does that. He says, okay, I'm talking about this fundamental substance called monads, which, is pretty clear. I understand that.
But we don't know what a monad is in comparison to particles that we do know about, like electrons, positrons,
we know them both equally well. I mean,
I understand what Bill says when he says that word, because I'm familiar with the literature and the terminology from which it arises. And as I understand it, that's the modern use of the word monad goes back to Leibniz.
No, it goes way back to Moshe.
I said modern.
Yeah, modern. Well, Newton knew about it, and all those type of people. They was taught in every university in Europe, and
yeah, but if you can't tell me how that relates to the known particles, then you might as well just say little green men. Really?
No, wait a minute. I've published a theory of elementary particles based on monads, and it's the geometrical combination of the monads and the type of vibration that structure can support that determines its mass, spin, and its charge. And those quantities are all predicted, and I predicted from electrodynamics, the field, basically. And I have no adjustable parameters. The standard model of elementary particles has between 19 and 29 adjustable parameters in order to try and predict the properties of elementary particles, and they represent still unknown physics, where I just use electrodynamics by itself, using the 6 empirical laws of electrodynamics as my axioms or assumptions. And
well, you did mention toroidal vortexes. Of course, I've been on the warpath against these things for years.
Wait a minute. The empirical equations of electrodynamics predict that.
Well, there's a certain.
I've been against that.
In defense of Bill, one of the big pluses to what Bill is saying is that he is basing his theory on scientific facts of experiment. And basically, one of my main criticisms of people who come up with ether theories is that they have no facts of experiments. They just invent an ether, and they basically have no facts or experiments that they put into the theory. It's all just philosophical speculation. It must be so because philosophy says so. That's not science. At least Bill's doing science.
Well, I've been showing some videos of what happens to toroidal vortexes when they encounter each other in a collision. So this is a real scientific experiment.
Yes, but a vortex is not the same as a soliton.
Not according to what I've read. I mean, your solitons are these toroidal vortexes, and these are toroidal vortexes.
No. Go to look at the work of Winston Bostick. You'll see they're not that way at all. A regular vortex has no lifetime that's thousands or millions of years.
And I would claim that that's circular reasoning. That must be false. I mean, a toroidal vortex is a toroidal vortex. It's a fluid mechanical thing. This is the only reason why people think it's stable, because it looks like it's somewhat stable when it comes out of the vortex generator.
Looks to me like what you've shown is annihilation of a particle and an antiparticle.
That's what it kind of looks like, but these are basically two of the same things. I mean, this is what's going to happen to anything that's fluid mechanical. That's my argument. That some people.
I'm not really sure this is relevant to the discussion.
It is. It's relevant that some people think that electrons are these toroidal vortexes. And if they were, this is exactly what would happen to them if they encountered each other. They would destroy each other.
The vortexes you're showing are disc shaped. They're not ring shaped.
The shapes that's shown in the Bergman electron ring model are exactly these things.
No, because the what you're showing in this video here is a disc, and the two discs are hitting.
And that's what a toroidal ring vortex is. That's what a toroidal ring vortex is.
No. You should look at what Winston Bostick has. The toroidal ring is it's like a circular ring, and then there's a second rotation around the cross section of the ring. And you don't have any of that in here. You have just a simple vortex. This is a more elaborate structure than that.
Well, even if it were more elaborate, then that would just make it even more likely to blow apart when it collides into each other, right?
When a soliton of the electromagnetic field is put in a nuclear reactor, all the materials in the nuclear reactor are being destroyed by the processes in the nuclear reactor, except the toroidal ring.
Well, I find that logically impossible.
But that's experimentally observed, and that's why.
And no, it can't be observed because these toroidal rings are so tiny they can't possibly.
No, they can be made of different sizes. And
logically, that can't be true. Well, that what you're stating there couldn't possibly. There's no experiment that would allow you to determine that.
Winston Bostick did it, and he was able to photograph them. And
I have seen Winston Bostick's photographs, and they're of these very ephemeral, wispy things, which kind of look like a torus, but they more look like a spiral galaxy, is what they honestly look like.
And also, do you know what he was doing? Why was he working with these? He wanted to make a container to hold thermonuclear processes, because our reactors that where we were doing fusion, they destroy themselves after a while. And he was trying to make a new kind of bottle out of these toroidal rings because they were not destroyed by nuclear reactions, and they had the strength to presumably make a container, and they could be put together in different structures. But what he found is he couldn't find a way to put them into a bottle structure. He could make geometrical structures out of them, but not a bottle. And he never...
Well, once again, Bill, I've read all the things that you've sent me, but I have never, ever read anything from Winston Bostick that says that.
Well, look up his papers in the literature.
I've read all his papers in the literature. I've looked at the stuff that you've sent me.
Well, I only sent you the ones that I'm working on.
There's nothing like that.
But the other experiments are there. And
all I can say is I've looked. I've not seen anything like it. I mean, what I can see from Winston Bostick, it's reasonable stuff. His plasma experiments, like say, where he shows little pictures of them looking like barbells, that seems reasonable. But I've never seen anything in his books as you have described here. So, and it sounds really kind of unbelievable, really. So I'm just saying that I have not found any evidence to corroborate your story. And I've looked. That's what I'm saying,
Winston Bostick has hundreds of papers he's published. I'm sorry you only have a few that I've sent you.
Well, that's my problem.
Yeah, and some of them are classified, but most of them are not.
Well, if it's classified, then still I can't corroborate that.
Right.
I mean, I would generally disagree, like I said, with any notion that the electron is built out of anything. That would be my assertion, that I don't believe it's any kind of toroidal ring. I don't believe it's built out of the electromagnetic field. I don't believe it's made out of some fundamental ether.
Okay, well, the Standard Model doesn't agree with you. The Standard Model says that when you look at charged particles like a proton or a neutral particle like a neutron, and you see it is composed of secondary smaller particles.
Yeah, protons and neutrons are definitely composite particles, but mainstream would agree with me that the electron is completely fundamental.
Quarks have a fundamental charge that is units of E/3, where E is the charge of the electron. And so the Standard Model says the electron cannot be a fundamental piece of charge, since there are smaller pieces that have a charge of E/3 or 2/3 E/3 or that sort of thing.
And how many quarks are in an electron?
And so they don't have quarks in the electron. They have something else, such as, the monads would be one.
No, what does mainstream say? What does mainstream say? How many quarks are in an electron?
Well, in my published theory of elementary particles, there are three monads in
No,
an
I'm not asking you. I'm asking mainstream.
Okay,
Because
well,
the answer is none. There are no quarks in an electron.
that's right, because quarks are too big. They have too high a mass already. You need to have.
So we've got this funny thing where they say that quarks are fundamental, but yet we have this other particle, an electron, which is apparently even more fundamental than a quark.
I have
Because
published.
it's not made out of quarks.
I have published a theory of elementary particles, and I explain all the elementary particles, including quarks, and I give their structure in terms of monads. And guess what? I have no adjustable parameters, and I predict the properties of elementary particles better than any published theory of elementary particles other than my own. But you know what? And I've presented these at international scientific conferences, not of alternative scientists, of regular politically correct scientists. They hate to see that, but they know that they can't refute it. And so I've been to Europe, I've been to Great Britain and Germany and Spain and France and Ukraine and Russia. All these places I've presented this, and that's they know about it, and they are trying to find something wrong with it, but they have a problem. It's too simple. And it also,
well, I mean, the basic problem here, I mean, you always claim that if your theory makes assumptions, and if those assumptions are false, then no matter how successful your theory is, all your conclusions are in fact false.
Yes, so we don't use the scientific method today, but we did in the past.
Well, the assumption that you're making here is that electron is made out of the electromagnetic field in the form of a toroidal ring. That's a gigantic, unproven assumption.
That is not unproven. That comes directly from the 6 empirical laws of electrodynamics. You see, no one other than myself and Maxwell tried to do it, but he didn't complete the job, has solved those 6 empirical equations of electrodynamics simultaneously to get the most general solution. For instance, the current solutions to 4 of the 6 equations, Maxwell's equations, give you the electric and magnetic field and electromagnetic force as a function of radial terms and velocity terms, because they use the vector potential. If you use the energy potential and you do all 6, you get the electric and the magnetic field and the electromagnetic force as a function of radial terms, velocity terms, acceleration terms, and radiation reaction, dAdt terms. Okay.
Now, we've heard all this, but all of that still doesn't logically lead to electron being made out of anything.
There's 3 terms for the radiation reaction terms in the electromagnetic field, and 2 of them have boundary conditions on them, and the third one is exactly what we measure in accelerator experiments, in elementary particle experiments. So in order to get to agree with data, the 2 that have boundary conditions on them must evaluate to 0. If you ask under what conditions do they evaluate to 0, the answer is that all electromagnetic structures have to consist of these monad toroidal ring objects.
But you still can't explain what the electromagnetic field is that these things are made out of is. That's a huge hole.
So the electromagnetic field is what is observed. We don't know what it is made of because it doesn't have any mass. But
and that's a huge problem. I mean, that's kind of the same problem we have with all ether theory.
And we also know that some aspects of the field cannot be shielded. So we know there's no way to keep the electromagnetic field from permeating all of the universe.
Yeah, but if you don't know what the electromagnetic field is, you don't know nothing.
But experimentally, we measure it. How much do you want to know about it?
We want to know how it propagates.
We
want
don't
to
know
know
anything
what
about
it
the
is.
electron because all we can do is measure it.
We want to know what the difference is between a positive charge and a negative charge, and you still can't explain that.
And what this says is charge is a mathematical approximation, just like mass was when we did the force of inertia and the gravitational force. They put it in as the constant because they didn't know what it was. And if you ask Newton or Einstein what is mass, he has to say, and he did, both of them did, I don't know. It's a property of material. And so in order to write an equation, I want to put an equal sign in there. I have to put a constant representing this property. So
yeah, but a positron and electron attracting each other is not an equation. That is a physical phenomenon.
But anyway, see, I can predict the mass of all the elementary particles. I can predict it in an equation that's electromagnetic. So that mass is obviously an electromagnetic property of structures.
Well, I would totally agree with you there. Mass is totally an electromagnetic property. Mass is not an inherent property of a particle. It actually depends more upon its environment than anything inherent in the particle.
Well, can you predict the mass of all the hundreds of elementary particles that have been observed experimentally?
I can't, but maybe that's because I haven't tried.
Yeah, I think they should try. Because your theory has to be able to explain all that.
But I'm saying that where your theory is wrong is this fundamental ether issue, which is what is at the basis of everything. So your theory, and my criticism of your theory is that starts with this electromagnetic field concept, which you cannot explain.
But
that is my main criticism of your
laws
theory.
Of electrodynamics. So,
and no matter where that comes from, that is a gigantic hole in your theory compared to, say, other theories where, for example, by
this theory
comparison,
is a scientific theory, and what you're saying is I don't believe in scientific theories.
No, I believe in scientific theories which are well grounded in things that we know about. Now, as soon as you retreat into something like the electromagnetic field, then you've left that.
See, I'm only using all my assumptions are built into the empirical laws of electrodynamics. Your assumptions are
science. What he's basing his theory on what is known through experiment. That means it's a scientific theory.
And if you disprove one of those empirical laws of electrodynamics and get a different law, then I need to take that into account in my universal solution, general solution of electrodynamics. And so I have a way to I have a procedure to correct the theory if someone finds anything wrong with the empirical laws of electrodynamics. But
the thing is that the empirical laws of electrodynamics should be derivable, because the empirical laws of electrodynamics are clearly not the most basic thing, I don't think. That you need to have a theory that
that's a claim on your part.
Is what you need.
But see, the empirical laws of electrodynamics enable me to predict the force of gravity, and that force of gravity that I predict is better than general relativity theory or Newton's universal law of gravitation, in that it predicts properly the gravitational field in our solar system toward the edges that was measured by Pioneer 10 and 11, and it properly predicts the high velocity of the outer spiral arms of spiral galaxies, which these other theories cannot predict. And we had to invent dark matter and dark energy, which we've never observed, in order to rescue those theories, because without that they couldn't predict them. But my theory of gravity.
Michael wants to say something. Michael, do you have something you want to say?
Well, regarding experiment and proof, the code reference that I mentioned also gives the directions for performing a field test to elicit an etheric energy field. And then if you could produce an energy field like that, you could decrease the density of material inside the test system which would be called a levitational effect. And this could prove the existence of, well, it wouldn't prove the existence of an ether, but it would be a predicted effect and would be very strong evidence for the existence of an ether. But it would be expensive to set up this field test, and I don't have a financial sponsor. I haven't been able to find anybody willing to put up the money to do it. But
so what do we need to do to set up this experiment? Maybe someone watching will fund you. So what do we need to do?
Well, I need to find somebody with the money that wants to do it. That
Okay, let's presume I've got like Bill Gates and he's got the money. So what do you want to do?
Well, I can't give the exact description of the test over over the internet, because that would be giving the whole thing away. I might as well not even be in it. But I'd be certainly open to discussing with anybody that's seriously interested to do it. But I can't give it out the whole thing here. It's a field test, and it would be quite expensive. It would be run into the tens of millions, lower range of tens of millions, 8 figures, to do the whole thing. So
well, they've done experiments like that, like CERN. They spend that much every year. So
I tried the Department of Energy.
This is what I don't understand about people who say this kind of thing. It's like you're trying to make money or something like that. And you're trying to give away, they can't give away their secrets. But, I kind of consider that BS, really, because it's like you'd be lucky if anyone, believes you enough to give you that money. And we're not in it for the money anyways, or the fame. We're just seekers of truth, right? So I just don't believe that kind of argument, really. I think it's a smokescreen.
Well, as far as evidence goes, I think the best way to conceptualize my model would be to look at quantum entanglement, and quantum entanglement would represent radiated packets of etheric energy which have the same vibratory pattern, elemental etheric units.
Let's talk about quantum entanglement, okay? Now, I think that's a lot of baloney from the quantum mechanical sense, because all that means is that I take like a right-hand glove and I take a left-hand glove. So we have that. So I take my right-hand glove and I send it to Boston. Okay. And then I take my left-hand glove and I send it to Seattle. Now, when I go and open my box in Boston and I see that, oh, it's a left-hand glove. And I say, you know what? The glove in the Seattle box is a right-hand glove. And when I do it, I said, in fact, that's true. And this is what quantum entanglement is. You start with something which is left and right-handed. You separate them at birth. So if you look at the one, you know what the other is. And that's without any communication of any type. It's just that's just a geometrical property of these particles that you're using. One is left-handed, one's right-handed. So, and they're generated in pairs. So I just find that whole thing to be like a non-issue, really. It's like it's intuitively obvious that's what should happen. There's no mystery about quantum mechanics.
Well, that's your opinion. There are a lot of other opinions about it that that are more entertain it quite seriously. So I don't know.
They entertain it quite seriously, but that's in fact what it is. It's like there's no mystery to it at all.
Well, that's your opinion.
There's absolutely going to be a correlation between the particles after they're separated, right? And that's because there was a correlation before they were separated, right? There's no communication. There's no entanglement.
Well, there are dynamic studies that show changes going on that, that are not, reproducible by by that kind of explanation.
No, I'm pretty sure there isn't. There's no thing where you can say, I take my right-handed glove, I turn it left, and then suddenly the left-handed glove turns right. That never happens. They tend to imply that, but no experiment have I ever looked at ever does anything like that. It's always look at the left glove, the other one is a right glove. That's what the correlation is. There's never any actual communication required to get this correlation.
Well,
I'm just saying that whole entanglement stuff is a lot of baloney. And if your theory kind of relies on that, then that too must be baloney.
Well, no, I'm not saying it relies on it, but I think it's the best explanation, the best evidence for it.
Now, I do find things that I would agree with you in your theory. For example, that there is an ether. I totally agree on that. I would totally agree that the ether itself is extremely dense. That the space in front of me, uncountable trillions, even in a cubic centimeter, billions, trillions. It's in fact the densest substance ever. But where I would disagree with you, and where I would agree with Harry, is that if you're going to call that thing an ether, you have to make it out of something. So I don't retreat into this thing that my ether, there was some primordial form of my ether, and then some granular form of my ether arise out of that, and then out of that arise things like electrons. So
I think there has to be a beginning to anything has to have a beginning. And,
so what my idea is, my beginning is I just start with electrons. This is why I argue against electrons being made out of anything, right? I say we know what electrons are. Definitely those things exist, right? So I don't have to explain the existence of electrons because we know they're there. Neither do we have to explain the existence of positrons because those things are there.
Where did they come from?
They don't have to come from anywhere. This is what I'm saying. I don't have to explain where electrons and positrons come from because they are clearly already there to work with, right? Well, see, so I don't have to explain where electrons come from, really. I almost don't have to explain what they are.
Well, to me, you do.
What is required is that science recognizes they exist and that they are fundamental. And there's definitely two things that mainstream science does absolutely recognize. They recognize the fundamentality of electrons. Like I said, in standard theory, we have quarks, but quarks somehow don't fit in with the electron. There are no quarks in an electron. So how could quarks possibly be fundamental? The only thing that can be fundamental in that picture is, in fact, the electron, which no one has ever been able to break apart into anything. So that's why I make I'm talking about my theory. So Michael, you can tell me what you think of my theory, which is that space itself is made out of nothing but a sea of positrons and electrons. That's my conception. But that matches your conception that ether is omnipresent, that it supports, it's a medium for waves, and it definitely oscillations are an important part of that. As oscillations are an important part of my theory. Because like I asked the question, well, what's the difference between positron and electron? Any ether theory needs to be able to precisely describe what the differences are because they react very differently.
Well, it doesn't make sense to me. You have a bunch of electrons. Where do they come from? You have to have an initial beginning substrate to...
No, you do not. Why do I need to explain where electrons come from? They're clearly there. Do I need to explain where the electrons in this calculator came from? I don't think so. We know they're there, though, right? Why do I need to explain where electrons came from?
Well, I think it's key to the whole thing. That's
why?
Well, because you have to have a beginning substrate to go from to go.
Well,
further.
The beginning substrate is right in front of us. We have this substrate of electrons, positrons, and neutrons. We definitely have that. So why would I need to explain where it comes from? I mean, it's like right?
Franklin, I think his point is that if we can describe and explain the origin of everything else, including the ether or the medium of nothingness that exists, then that means that we should or could quite possibly be able to explain where electrons are, or their origin or their basic structure. And if we understand that and can explain that, that would help us solve and resolve the questions regarding the other non-elementary elements.
But that's exactly what I'm arguing against. I'm arguing that it doesn't matter where the electrons came from. We know they exist. As far as we know, they've always existed. And there's no human being going back far enough to see where they came from. That's why, see, my main point here, in contrast to what Michael and other people are arguing, and this is why you want to have an origin story, because you want to make the electron out of something. But I'm saying that from my point of view, that is a very wrong position to be in, because the electron is in fact not made of anything. An electron is in fact completely fundamental, and I don't care where it came from. It doesn't matter where it came from. We know they exist. Therefore, I should be able to use that in my theory of the ether without any other reference required. So my only assumption in my ether theory is that the electron and positron exist. That's it. Now, as an assumption goes, I would say that's a pretty well experimentally proven assumption. That we've got lots of experimental evidence to suggest that those things exist. And I'm saying that it's not helping our cause to try and say that that electron is made of anything. That's only confusing the issue in my mind. Because if you do, then you're trying to say that there is this, say, electromagnetic field or this primordial ether, which we don't know what it's made out of, and you can't describe how many of these ether units make up an electron, or how is it they gather up to make an electron. That's why this whole toroidal ring thing came about, because people want to, make an electron out of, say, something. This toroidal ring model, they say, is made out of 3 1/3 charged fibers. But that doesn't make any sense, because if you make an electron out of anything made out of charges, then those charges will repel, and you'll have this big problem that it's not going to be stable because it's going to blow itself apart. So I'm thinking that an electron is not made out of anything. It can't possibly be made out of smaller negative charges. It has to be fundamental. It is a generator of charge. It generates 1 unit of electrostatic charge. But the substance of the electron itself would not have any charge itself. It's like a speaker, right? A speaker that generates sound. So a speaker is not made out of sound waves. It's a mechanical thing that vibrates. And so I think that's what an electron must be.
Franklin, there are those that indicate that or suggest that there are other fundamental elements that are lower than the electron. And if we were to presuppose for just one moment that those are true, then understanding the electron is critically pivotal to understand the whole mass. If we allow ourselves as philosophers to ignore understanding one portion of this creation or this magic universe we live in, and not leave the door open to potential understanding and breakdowns of it, so that we can apply that to the rest of it, I think we're selling ourselves short.
Well, I would actually argue the opposite way, because I think that by and large, most of the dissident community believes that an electron is made out of something else, and they're desperately trying to do that. I mean, the vast majority of people have done that, and I don't know how far that's really gotten us. I don't think that's really gotten us very far. So I think that it's time to reject that hypothesis, and it's time to adopt what we know from empirical evidence, which is that the electron is fundamental, that it's not made out of anything. We've never been able to break it into anything. There's no evidence of any kind, experimentally, that an electron consists of anything. I mean, we can see that in the proton. We can see that in the neutron. We can even see that in every other particle that decays. But when it comes to a positron or electron, that appears to be the bottom. So all of this effort, and this is why I'm trying to, emphasize this, all of this effort upon trying to find something lower than the electron, I believe, is wasted effort. So that's just my assertion, and that's what I would try and convince people of, that looking beyond the electron is a fruitless effort. Because, like I said, most people will do that. As near as I can tell, they've all failed. So I would think that after thousands of years of failure, that is sufficient evidence that we should reject that hypothesis.
I don't
They've
think
only failed so far, Franklin.
That's right, for thousands of years. So I say we try something different.
I don't think my ether theory has failed. It just hasn't been entertained enough. You have a vibrating elemental unit that arose from oscillation and went to vibration, and the vibrations form entrainments, and the entrainments form larger and larger aggregate units, and this is how you can form an electron.
Well, honestly, Michael, I've heard you. I'm not a mainstream scientist myself, but there are just bucket loads of things missing in that theory. It's like, first of all, your initial hypothesis that there is this primordial ether. Well, that by your own admission is just something completely, that's just has to be one of your assumptions. But we don't know what that is. Now, given that we don't know what that is, there's no way for us to logically say that thing can have vibrations in it. How can something we don't know what it is have any vibrations in it? The only thing that we know can have vibrations are things which are like a medium of some that have mass and stuff like that. So right away, your theory fails on that alone. Just from the very get-go, there's no way you can explain your basic concepts.
If someone entertains the validity of quantum entanglement, that would have to be via vibration of elemental units.
Well, as I explained, your quantum mechanical thing, entanglement doesn't really apply here. Quantum mechanical entanglement does require the presence of two opposite things. And
the quantum units are made of the elemental units, and that's why they resonate, because the elemental units are what made the quantum units, and the elemental units also form the matrix, and that's how the vibrations are transmitted to it from one quantum unit to the other.
Now, see, all those things I could agree with if you just replaced your quantum units with positron and electron. And that's exactly how it works in my theory, which is that, you said you have this yin-yang thing. And in my view of the ether, yeah, you do have the yin-yang, because every quantum of the ether is made out of a positron and an electron. So there's your yin and there's your yang, right? Now, I asked what to explain, say, pair production. And that is, the apparent appearance of a positron electron out of empty space. Now, one of the predictions is if all of space is made out of a positron electron, then you ought to be able to split up one of those pairs so you could see the separate positron electron. And that is exactly what we observe in pair production, where you send a quantum of energy, it's a gamma ray, but really any super high energy event will do. And you can break up what space is made out of, which is positrons and electrons, so you can see the separate positron and electron. And the only thing you need to do to break up the positron electron is add sufficient energy to do so. And so this is why in accelerator experiments, I feel like the main thing that you see coming out of accelerator collision are, in fact, positrons and electrons. And positrons and electrons that cannot be accounted for from the original colliding constituents. So I'm saying that, your theory has all the right elements in it, but you're retreating to this idea that your fundamental ether is something mysterious. I'm saying all you have to do is, instead of having mysterious primordial ether, is to just substitute positron and electron. And then suddenly everything that you're saying makes physical sense. What do you think of that? I mean, could the positron and electron be your fundamental ether unit that you're talking about? Could it be the fundamental ether unit that Bill was talking about, which is the monad? It sounds an awful lot like that, but I don't know why you guys just tend to reject that idea that the fundamental unit is, in fact, the positron and the electron.
Well, Bill's monad sounds a little bit like my elemental ether oscillational unit that transitioned to a vibrational unit, which has
But it doesn't sound like my positrons and electrons?
Well, you're proceeding from our quantized environmental experimental world, which is different from the ether. Is not observable. It's not testable, except in this field test that I'd like to get done, but I don't have the money to do it.
I mean, the thing is, if space is made out of positrons, electrons, first of all, the most obvious experiment is to show that you can eject positrons, electrons from an empty space. That's already been shown to be true. The other thing that you could predict is that if you put positrons, electrons together, that they would form a new ether unit and that they would effectively disappear. This is also proven, right? If space is made out of positrons, electrons, I believe clever scientists could prove it, right?
Franklin, that's not true about the forming of pairs, like the electron-positron pair, in an accelerator which has a, quote, vacuum in it. We accelerate protons to high energy, and they go around and around millions of times, creating no electron-positron pairs. Then we bring them up near a target of either an atom or another elementary particle. And when they hit that target, they make pairs. So
if that's perfectly consistent with my theory.
No, because your theory says that they should still be able to make a pair. And we can have light going through the vacuum and makes no pairs. But when that light hits a particle, it can make a pair.
That's because the thing is, it's very difficult to, this is why pair production must in fact happen in the presence of a large nucleus. It's a recoil problem because you can sit there and within the sea of electron positrons, you can shake that thing as hard as you want and they're not going to come apart. The only way you can ever get it to come apart is that you have to actually collide it with something else so that there's enough kinetic energy to allow the pieces to separate, right?
Well, the electromagnetic energy of gamma rays and that sort of thing is plenty of energy.
Yes, there's plenty of energy, but the thing is, it's like, I don't know, it's like trying to shake a tree or something. You can't shake it enough. Although that's still not a bad. That's still the thing is that you can put an infinite amount of energy through the ether, and because everything just flows naturally, there's no way you're going to break that thing apart. The only way you could ever get that thing to break apart is you actually run into something, right? So that something stops one of these ether particles, like a large nucleus. Then this can go that way without this thing going that way, right? That's the only way. Otherwise, if they're like this, they'll just keep on doing that. If you break this, then that's the only way they can separate.
But see, in atoms, we can easily cause the electron to capture the energy from light.
And that is also not relevant. I mean, that's a separate electron. We're talking about positron-electron production here from empty space.
We can do. That's what happens when we put high energy on an atom. It doesn't make it to the nucleus. It's on the outer part with the electrons, and we get electron pair production. And but you're saying we can't do that if the electrons are in the vacuum or the ether, because the electrons there can't act like the electrons do in an atom.
No, actually they do. I mean, the whole Lamb shift is actually based upon there being this positron-electron sea. I mean, that's the way mainstream, this is where they come with the concept of virtual particles, because they feel that the only way they can explain the Lamb shift is with the existence of virtual positrons and electrons. Because as near as I can tell, that's the only way they can explain the Lamb shift. But I'm just saying that those electrons are there, one. Two, they react exactly the way we think they would, leading us to do things like explain the Lamb shift, because they're not virtual. They are, in fact, there. So the Lamb shift itself is very good evidence that space itself is filled with this positron-electron sea. So, but that's why I'm trying to get away. I mean, my main point here, so we're talking about the ether. So Michael's talking about his ether. The main problem, I think, is this non-definition of what the ether is. No one wants to say what the ether is. And I think, Harry has a very good point here that he doesn't understand any of this stuff because he doesn't know what the ether is that you're talking about, right? And I agree with that. That's a big problem. So you got to put the rubber to the road. And I say that rubber is saying that that ether is made out of a specific substance. It's made of positrons, it's made of electrons. By our normal definitions, they do have mass. And in fact, some people, I mean, this is not my theory. This whole idea that there's this positron-electron sea. Lots of people have done work on it. Lots of people have done calculations on it. And it's like super dense, like 1 million times denser than, say, steel by their calculations. So you got this super dense substance, which I believe you could perform experiments to actually find it. And that would be the ultimate thing to prove that the ether exists. Just be able to just arbitrarily break apart the ether into its positron-electron components would probably be a proof that the ether exists. But if your ether is this mysterious substance, electromagnetic field, little green man, whatever you call it, then no experiment can ever find that. But if your ether is made out of positrons,
electrons are based entirely on field. We can't measure any property of the electron other than the electric and magnetic field it has and its mass. That's all we can measure. We can't treat it like a billiard ball. We can't tell what its size is except through the field.
I mean, we can't treat it like a billiard ball. We can collide these things and we can say, yeah, they definitely act like billiard balls.
They don't hit. It's the field at a distance that causes them to move. And it's at all different distances depending upon how much energy they have.
No, I think that's a misconception because I think ultimately particles like protons, electrons, they act like billiard balls.
I worked with accelerators for many years. I know that's the truth. I helped make the measurements on those things.
And you see them collide, right?
They don't touch.
How do you know they don't touch?
Because they scatter off one another at various distances. They don't actually touch.
And how do they scatter off of each other, right?
Fields are doing it, not hard entities. Fields. Fields are more fundamental than particles and charges.
Now, see, that's another thing I disagree with. Because fields fundamentally cannot be fundamental. They always rely on particles. So particles themselves must be fundamental. That's whole nother issue, which I think is completely backwards. To say that things like fields are fundamental, that is backwards. But in any case, it looks like we're getting towards the end of our talk here. I'm just telling you, Bill, that's my opinion.
Yeah.
Fields are not fundamental. That's backwards. Anybody who thinks fields are fundamental has got something totally wrong. So that's just from just pure logic.
Well, in quantum mechanics, everything's in terms of the universal wave function.
And that is, in fact, completely wrong as well. That's
you're saying the theory of the atom and the nucleus and elementary particles are all wrong. Okay.
That's right. They're all wrong.
So
I would totally agree with
no such thing as an electron.
All of that stuff, wrong. So But that's what we're here. We're here to talk about stuff which is controversial. And so today we've had Michael Anteskis here, and he has described his model of the ether. And like I said, I would have very much to agree with his model if he would only make the simple substitution that his fundamental prehistoric ether unit is just a positron and electron. Then I could see that it relates to the real world. As long as your fundamental ether unit is not anything that we can touch, feel, or experiment with, I remain extremely skeptical. But it's always a good discussion about what the ether is. Like Harry is very adamant in saying that he wants it to be a material thing, which I totally agree with, versus a little green man or fairy or fundamental ether unit or muon or what have you. And I would totally agree with that. But we have had an interesting discussion, and I think that will wrap it up for this episode of the Science Chat. And I thank all the participants in it, and hopefully we come away with some different ways of thinking about things. So at least I've tried to push forward a little bit of my agenda about, say, the fundamental property of the electron, it being fundamental, it being fruitless to pursue any further research on what that thing is made out of, or in fact where it even came from. But that could be a discussion for another time. But for now, that will do it, and we'll be signing off, and hopefully we'll see you next week.